Today, I'm going to explain first part of further aspects of Equilibria. Kw is the ionic product of water. The value of Kw varies with temperature. At room temperature, this is equal to 1 times 10 to the power of minus 14 mole squared dm minus 6. Let's talk about this in more detail. Kw actually derived from Kc expression. As you already know, water dissociates into H plus and OH minus ions. We can write this in Kc expression. The important point here is that Equilibria lies well to the left because water is very weak at dissociating. Therefore, we can assume that concentration of water is almost constant. By removing constants, we can then express Kw. Let's move on to pH calculations. pH is defined as the negative logarithm to the base 10 of the hydrogen ion concentration. In simple, this is written as hydrogen ion concentration is equal to the 10 to the power of minus pH. We can use these two equations to convert from pH to H plus concentration and from H plus concentration to pH. Let's solve practice question. First, calculate the pH of a solution whose H plus ion concentration is 5.32 times 10 to the power of minus 4 mole per cubic decimeter. First, write down the pH equation, and then put H plus ion concentration into the equation. Use your calculator to find the answer. Let's solve practice question. Calculate the hydrogen ion concentration of a solution whose pH is 10.5. First, write down the H plus ion concentration equation, and then put pH into the equation. Use your calculator to find the final answer. Now let's solve SAQ 1 and 2. These are the answers for SAQ 1 and 2. Now let's move on to pH calculations. pH of strong acids. Strong acids completely dissociate in solution, so concentration of H plus ion is equal to concentration of acid. This means pH can easily be calculated by using this equation. pH of strong bases. To work out the pH of a strong base, you have to follow these steps. First, calculate the concentration of hydroxide ions. Second, calculate the concentration of H plus ions using Kw. Last, convert H plus concentration into pH using this equation. Calculate the pH of a solution of sodium hydroxide of concentration of 0.05 mole per cubic decimeter. Since the concentration of hydroxide ion is already given, we can use Kw to find the concentration of H plus ion. Then we can put H plus ion concentration to the pH equation to find the final answer, pH. Let's solve SAQ 3. These are the final answers. Now let's move on to Ka, acid dissociation constant. It is the equilibrium constant for a weak acid. We can express it like this. The lower the Ka value, the lower the concentration of H plus ion and an ion, so farther left the equilibrium lies. In other words, the lower the Ka value, the weaker the ionization. For weak acids, the Ka is very small, so Ka values can be converted into pKa values using the equation below. As pKa increases, the strength of the acid decreases. Calculate the pH of 0.1 mole per cubic decimeter ethanoic acid. In this question, Ka is already given. First, write down the general equation involving dissociation of ethanoic acid, and then write down the acid dissociation constant. From this expression, you can calculate the hydrogen ion concentration. Put Ka value and concentration of acid into the equation and use your calculator to find the H plus ion concentration. Then put H plus ion concentration into the pH equation and use your calculator to find the final answer. Let's solve SAQ 456. These are the answers. Let's move on to indicator. Indicator is a weak acid that changes color when it donates a proton. We can draw a titration curve to show how pH changes during an acid-base titration. Titration curves are used to select appropriate indicators for acid-base titrations. The important point is that the indicator must change color on the vertical section of the graph. In other words, the indicator must change color within the endpoint of titration. For example, if we draw a strong acid, strong base titration graph, there is a sharp fall in the graph line between pH 10.5 and pH 3.5. A midpoint of the steep slope is at pH 7. Bromothymol indicator changes color within the endpoint of titration, so it is appropriate indicator. Besides from strong base, strong acid titration graph, we can draw titration graphs of strong base, weak acid, or weak base, strong acid, or weak base, weak acid. How to distinguish different kinds of graphs? If you look at this graph, as highest pH is at pH 11 and the lowest pH is at pH 1, you can find easily that this is weak base, strong acid titration graph. Also, by looking at weak acid, weak base titration graph, we can find out that there is no sharp fall in the graph line. Therefore, no acid-base indicator is suitable to determine the endpoint of this reaction. Now, let's solve SAQ 7 to 8. These are the answers.